Hey guys, welcome back to my channel, and in today's video we are going to solve one more LeetCode question, that is question number 1609, that is even odd tree. So this is a medium level question and it has been asked by I guess Amazon and Bloomberg. Yeah, so in last 2 years this has been asked by Amazon and Bloomberg. So let's see what this question is all about. So in this question we are given a binary tree and is named as even odd if it meets the following condition. So we have to check whether a binary tree can be named as even or odd or not. So what are the conditions? So the first condition is that the root of the binary tree is at level index 0 and its children are at level index 1 and their children are at level index 2 and so on. So this is the first condition. So I guess this is the basic structure of a binary tree. Then the second condition is for every even indexed level. So for every even indexed level, all nodes at the level have odd integers value in a strictly increasing order. So if the level is even indexed, then all the nodes at that level have odd integer values and they will be in a strictly increasing order from left to right. And if the level is odd indexed, then it will consist of all the even integer values and they will be in strictly decreasing order. So these two conditions are something we need to take care of, and at the end, if these two conditions are met for all the nodes at all the levels, then we will return true, else we will return false. So if we see this example, in this level 0 is having value 1. So 0 is an even level, even index level, and 1 is a odd number. When we see a odd index level, that is level 1, we can see that all the values are in strictly decreasing order and are even, right? As written in this condition, if the level is odd, the values will be even and they will be in a strictly decreasing order. So these are the things that we need to keep in mind while solving this question. So let's see how we can solve this question using this example. So if we see this binary tree, I have already drawn its index levels, and these are the node values this side and these are the level indexes. And now we will see how we can solve this question. So we are well aware of one thing, that any tree can be traversed using two algorithms, and that is DFS and BFS. So as this question is majorly focusing on checking all those conditions in level order manner, right? We need to check that whether this is a even index level or odd index level. Then in this case, it would make more sense if we are going to use an algorithm which is more focused on level order traversal. So for that we will use BFS. We can solve this question using DFS as well, there is no harm in that, but for this video we will focus on BFS and we'll see how we can solve using BFS. So in basic BFS, what happens is we traverse any tree in level order traversal manner. So the BFS maintains a queue, and inside that queue all the nodes of that particular level are inserted, and then one by one we pop those nodes from that queue and we will access their child and insert them back to queue, so that when we will reach the next level we can again access those values. So this is how the BFS works. So now how we are going to utilize BFS for this question. So there are few things that we need to consider rather than performing plain BFS, because we need to check whether this tree is following even odd condition or not, right? So firstly, we will maintain a level flag which will let us know that whether the level is even or odd. So for that we can name it as even. So right now I am denoting it with E and I am assigning it as true. Why I am assigning it even as true? Because we will start from this level which is 0, and we know that 0 is an even number. So it will make more sense when we start traversing and our flag is true, which is indicating that our level is even. So when our level is even, what we need to make sure is that all the values in that level is odd and are in increasing order, strictly increasing order from left to right. So strictly increasing. Then how we are going to check whether these values are in a strictly increasing or decreasing manner? So for that, what we can do is we can maintain a variable named previous. And what this previous will do, with the help of this previous variable, we will check whether the current value is in increasing or decreasing order as per the requirement of our level, right? So for now, as we are in even index level, so firstly we will come to this place, we will check what the value is. Value is 1, so we will assign previous 1. 1 is odd number, right? So this satisfies the first condition, that when the level is even, our value is odd. And as we can see that there is only one value, so we don't have to check or have to get bothered about whether the rest of the values are greater or are in increasing or decreasing order. So for this level, we are having all the conditions satisfied. Now we will proceed to next level. Now when we are changing our level, our this E is going to be updated. That is, even flag is going to be updated and it will become false because this level is odd level. And we know that when the level is odd, we need to check whether all the values are even and they are in strictly decreasing order. So firstly, I will come up to this place. I will check whether this value is even or not. So we know that 10 is even, right? So when 10 is even, we will assign it to previous. Now I will proceed to next node and I will check whether this is even or not. This is also even. Now I will check whether this is in decreasing order or not. So I will check it is lesser than previous or not. So this is true. This is lesser than previous. So both the conditions are satisfied, right? Our previous value is greater than the current value. So this is in decreasing order. And when the level is odd, our values are even. So this level also is passed and satisfies all the condition of even or tree. So now we can proceed to next level. Again, our E is going to get updated and it will become true because this is even level. Again, we will do the same thing. We will come to this place. We will check whether the value is odd or not. So this is odd. So again, we will assign it to previous and then we will proceed and check whether the next value is odd or not. So this value is also odd. Now we will check whether this is in increasing order or not. This is greater than the previous value or not. So this is also greater. So this also satisfies the condition because this is greater than our previous value, right? So now what we can do is we can update our previous with this value and we can proceed to next node because there are more nodes in this level. That's why we updated our previous again. So now when we are reaching this node, we will again check the same thing, whether this node is odd or not. So this is odd. Then we will check whether it's greater than or not from the previous value. So this is greater. So this whole level is also in strictly increasing order. So it satisfies the condition of even or tree. So we can proceed to next level. So again, our E and P will be updated. So our E will be again false and our P will be some negative infinity values. So when we are updating our E, we are also updating our P, right? Because every time a P is going to be initialized with the first value of these nodes. So every time you can make your P as well as infinity and minus infinity depending on the level. So for now our E is updated and we will reach to this place where our 12 is positive or even number. All the numbers are positive, so this is even number. As our 12 is even and our level is odd, so this satisfies one condition. So we'll assign this value to P and will proceed to next level. We will again check whether this number is even or not. So this number is also even and this is lesser than the previous value. So we will again update our previous value, proceed to next node check its value is even or not. So this is even and this is lesser than the previous value. So again update the previous value, proceed to next node, again check the same thing, check whether this is lesser or not. So this is how we traverse the whole tree and we reached the end of it. So this level also satisfies the even odd condition, and because all the levels are satisfying the even odd conditions, that's why this tree is a even odd tree. So this is how we are going to solve this question using BFS with few more variables and conditions in order to check whether these whether any tree is following the even odd conditions or not. And if any one of these conditions fails at any step or at any level, right away we will return false. But as all the conditions are satisfied and all the levels are satisfying all these conditions, that's why we are going to return true at the end. So this whole algorithm will take around big O of n time complexity and big O of n space complexity. Why this is going to take big O of n time complexity? Because we are visiting every node once. So n is the number of nodes and we will be traversing all the levels and visiting every node once. That's why time complexity is big O of n. And space complexity is big O of n because we are maintaining a queue of all the nodes, right? Firstly, we will go to this place and we will keep this in our queue, then keep its child in our queue, and then we are traversing and checking for all these conditions. Similarly, we are doing for other levels as well. So we are maintaining a queue of these values. This is the queue, right? So for that we will need big O of n space complexity. So now let's quickly code this whole solution. So firstly we will define our queue using dec function, and after this we will create a variable current and assign root to it, and then we will push this in our queue so that we will start our traversal. And before that we will create that flag that we use for checking the even and odd index level. So after this we will run a while loop, and we are saying run this while loop until our queue is not empty. So after this we need to calculate size of our queue, because this first while loop is going to take care of the level wise traversal, and the second while loop is going to be used for traversing all the nodes in a particular level. So for traversing all the nodes we need to know the size of the queue, right? Because at the starting we will have all the nodes of a particular level. So that's why we need to calculate the size, and depending on the size we are going to run the next loop so that we can traverse all the nodes in that specific level. So size will be length of queue, and after this we will define a previous variable. So let's make it max size. You can also use float, and we will check if so we can keep positive and negative. So right now we are assigning it with infinity and minus infinity, and in the next condition you will realize why I am doing this. I will explain it at that point. So here if our level is even, then what we are saying, make this previous value as minus of max size. So this is minus infinity. And after this we are going to run a loop while size is greater than 0. And inside this loop we are doing what? We are firstly going to pop a node from our queue, and then we are going to check those conditions like strictly increasing or decreasing, and values are satisfying the even odd conditions or not. So let's define it. So firstly, if the level is even indexed, then check current dot val modulo 2 is equivalent to 0. And if this is not true, so current dot val is, as we can see this condition, in this condition it is written, if the level is even, then check whether all the nodes are odd and are strictly increasing order. So this is the positive case, right? So but we are going to check the negative case. If level is even and values are also even, and if not even, then if values are in decreasing order, because we need to check they are in increasing order, right? But we are checking the negative scenario. So if the values are in decreasing order, then we will be returning false. So this was one case, and second will be if level is not even and the complete opposite of the first scenario. So if level is not even, so the value should also be not even. So the value should be even, but we are going to check for the negative cases. That's why we will simply check if these conditions are satisfied. If the values are even and level is also even, or if the level is even and the values are in decreasing order, and if the level is odd and the values are also odd, or the values are in increasing order, in all these cases what we have to do is we have to return false right away rather than proceeding and checking other scenarios and other nodes. So if these conditions are not true, then we will update our previous with current.val, right? We already saw in our explanation. And once we have updated, what we will check, if current.left is there, then append it in our queue. Queue dot append current dot left. And same we will do for current dot right. So if there is current dot right, then queue will be updated with it. So this is current dot right. And after this, what we will do, as we are running this loop for size greater than 0, so what we will do, we will decrement size. So size will be minus equivalent to 1, and this whole loop will run to this point where size is greater than 0. So after stepping out of this loop, we know that one level is done. So what we will do, we will update our level flag, that is even will be updated with an opposite value. So as I have added not in front of even, so if the value is true, it will become false, and if it's false, then it will become true. So this is how we are updating our levels. And once we are done with these things, so at the end we will return true. So after stepping out of both the loops, the first loop and the second loop, what we are doing is we are returning true, because if that condition that we are checking inside this loop is not true and we have traversed the whole tree, then this means that our tree is even odd tree. That's why we are returning true at the end. So now let's run and check whether this is working or not. I had made some mistake. Okay, so after this or, as I have added the another condition in next line, we need to add this backslash. I guess that's what the error was for. Yeah, so now this is working. So let's submit it and check. So this is accepted, and we can see that this was pretty straightforward BFS, but with few conditions that we are checking while traversing the nodes. So I hope this video was helpful for you all, and if it was, then like this video, subscribe my channel, and I will soon come up with more such videos. Till then, keep messing with algorithms, and thanks for watching.